shared the profile link before. Alright. Yeah. Let me check. Okay. All right. Good afternoon, guys. How are you doing? So, today, our first online class. Okay. We are going to be starting from inorganic chemistry. Okay. And we've gone a little bit far. Okay. So what we want to do today, okay, just to do some kind of preview of what we've done before. Okay, remember I told you that you guys are having two textbooks for this. Okay, so we have the basic inorganic chemistry, which is this, and we also have the inorganic chemistry, okay, and introductory course, which is the fourth edition. Now we've gone a little bit far in this one, and this one we've just taken what a little of it. So probably what we are going to do today, okay, remember I told you that the both contains similar but different contents, okay, different contexts. So what I'm going to do, we are going to do some teaching from this today, okay, probably subsequent time, okay, we'll go through this as well. Okay, remember I told you that B and C, they are the ones using this textbook. Then sorry, C and B and A, so they are the ones using this textbook. Why this one, okay, which is meant for the students. Okay, so now for the things that we've already done before, like I said, we are going to do some kind of review. Okay, please try to share this live streaming to your fellow classmates. Okay, if you know that you love them, so that they will be part of the class as well. Okay, so that they will be part of the class. Now, we are still on stoichiometry. Remember, I told you that stoichiometry is a very, very broad word topic, because under stoichiometry, so that's where you have your mass-mole relationship, then that's where you have your molarity. So we've not taken molarity. So that's where you have balancing of equation. So that's where you have the empirical formula and molecular formula, percentage composition by mass. So that's where you have isotopes, okay, atomic structures, and so many other things. Okay, so molecular stoichiometry is a very, very broad topic. Okay. So we are still on stoichiometry. We are still on stoichiometry. So your stoichiometry is the calculation of relative quantity, okay, of reactant and product in a chemical world reactions. Okay. Now from this other test I get, they started from balancing of equation. Okay. Now balancing of chemical equation. So just take some few part of it just to remind you of what we've done before. Okay, so balancing of chemical equation. Now, when it comes to chemical equation, when you are balancing an unbalanced equation, okay, now remember I told you the other time that now we have the reactant side and we have the product side. So what's chemical reaction? Okay, when you are transforming one or more new substances into another or new substances. Okay, that's called chemical what? Reaction. Then when you are now using what a chemical symbol to represent what happened in the reaction, it becomes what? Chemical what? Equation. And in your chemical equation, now assuming you are having something like this, which is H2O, so we have to give us 2H2 then plus what? O2. Okay, this equation is unbalanced. Okay, then before we balance it, please pay attention. Okay, this side, okay, which is my left side, is known as the reactant side, while my right side is known as the product side. Now, if you are turning it the other way around, maybe you are having 2H2 plus O2 to give us what? H2O. It's still the same thing. So this your left side is still called the what? The reactant side. Then while your right side is still called the what? The product side. Okay? And this plus sign here represents what? Reacts. The plus sign there represents what? Reacts. Remember, this side is my what? My reactants. Then why this side is known as what? As the products. Okay? Now, this arrow sign, okay, represent what? Yield. Either I call it yield, you can also call it what? You can also call it produce. Produce. Either I call it produce or use the word formed. Okay. Now, if you want to put this in terms of chemical reaction now, you can simply say 2 molecules of hydrogen gas react. You can see the plus sign there represents what? React. Though this first equation is known as what? Decomposition reaction equation. Okay, you can see the water decomposes to give us what? 2 molecules of hydrogen gas plus what? 1 molecule of oxygen gas. Okay, so this is a decomposition reaction. So when it comes to this one, okay, now this plus sign here represents what? Reacts. If you want to put it in terms of chemical reaction, you can simply say, now 2 molecules of hydrogen gas react with oxygen gas to yield. To what? To yield. Either use the word to yield or you can use the word to produce. Either use the word to produce, you can use the word to form. Okay, that is 2 molecules of hydrogen gas react with oxygen gas to form. To form, not form, sorry. To form, then 1 molecule of what? Water. To form 1 molecule of what? Water. So that's it. Okay, now, like I said before, this equation is unbalanced. Now, another thing again, when it comes to balancing of equation is this. When you are balancing your chemical equation, ensure that the numbers of molecules and atoms at the both sides are equal and equivalent, means that is they are what? The same. Okay, now this is it. If you have an element like this H2O, this thing simply means what's here is called atom. What's at this place is called atom. It simply means that here we have 2 atoms of hydrogen and here we have 1 atom of what? Oxygen. So here we have 2 atoms of hydrogen and here we have 1 atom of what? Oxygen. So when you now place any values at the back of this, okay, it's no longer called what? An atom. So what is here becomes what? A molecule. Okay, now this one represents 2 molecules of water. Now when there was nothing there, it simply means that you are having invisible one here. It simply means that this is what? 1 molecule of what? Water. Okay, now this is it. Like whenever you are adding a value to balance this chemical equation, that is a number. Okay, if you want to balance the chemical equation, you don't add to the front. You don't add to the front. You add to the back of the molecule. You don't add to the front. You add to the back of the what? Of the molecule. Okay, I can decide to add 2 here. I can decide to add 3 here. I can decide to add what? 4, depending on what I have in the other part of it. Okay, and another thing again is that, now please pay attention. Now, when you are adding a value to the bag, always start from the smallest. Always start from the what? From the smallest. Are you paying attention? Don't start from a bigger value. You can start from 2, you can start from 3, 4, 5, 6, 7, 8, and so on and so forth until the equation is what? Is balanced. Okay, now let's try to balance this. So we are giving 2H2 plus oxygen gas to give us what? H2O. Now this is it. How many hydrogen do we have? We have 4 hydrogen. How is it 4? You are using this 2 here to multiply what is here. Okay, now 2 times 2 will give us what? 4. That means here we have 4 what? 4 hydrogen. We have 4 what? 4 hydrogen. Then, why here? From this other side, how many hydrogen do we have here? Here is just 2. So here we have 2 what? Hydrogen. Hydrogen is 2. Here hydrogen is 4. Now to balance it, how many do we need to add here to make this 4? We need 2. We need 2 here to make it what? 4. So what do we do? We can decide to add 2 here. So this 2 times 2 will give us 4, and 2 times 2 will give us 4. So this time around, I now have 4 hydrogen. 4 hydrogen and 4 hydrogen. That my hydrogen is balanced. Then the next one there is oxygen. How many oxygen do we have here? We have 2 what? Oxygen. I have invisible 1 here. 1 times 2 is how many? 2. So here we have 2 what? Oxygen. Then why at the product side? How many oxygen do we have? Remember, I told you that this 2 that is here is affecting everything. Here I have invisible 1 here. Okay, 2 times 1 is how many? Is 2. It simply means that at the product side, we are also having what? 2 oxygen. So here we have 2 oxygen and 2 oxygen, 4 hydrogen and 4 hydrogen. It simply means that the equation is what? Is balanced. The equation is what? Is balanced. Okay, now let's move to the next one. Now, so hydrogen now is balanced. Okay, so the next step now, okay, is oxygen. We have oxygen here and we have oxygen. This plus here means addiction, and the plus here means what? Addiction. Here I have 1 oxygen here, and here I have 2 here. 1 plus 2 give us how many? 3. So that means my oxygen is equals to what? 3. Now if we share this other side, here I have 2 here, then here this 2 is affecting here, I have 2 here. So 2 plus 2 give us what? 4. That means here we have what? 4 oxygen. Now if you observe, this one needs how many? 1 to complete what? 4. Now this one is already 4. Okay, to meet up with this one. Now when you are adding, you add to the least side. You add to the least side. Now what do I mean by that? If I want to add, this side is smaller compared to what? To this side. It's small when you compare it to this other one. So definitely we are trying to balance this one so that it will be able to meet up with this 4. Okay, and if we want to balance it, here oxygen appear in 2 places here. Now the question is, should I add to this 2 or should I add to this 1? You don't add to this 2, you add to the smallest value, okay, which is this very one here. Okay, so what we are going to do now is to add up to this, and if we add up to this, okay, if we add one here